solving equations. And today's lesson will actually be maybe 2 or 3 portions, depending on the time. We'll be providing I'll be providing instructions or steps on how to solve equations, particularly solving the variables to that equation algebraically, as you can see here, or with algebra tiles. Now, it doesn't really matter which method that you choose to do. As long as you show some work and can demonstrate your learning and be able to solve the correct answer, that would be really great. So let's try this one example here. Now for this first example, I will be showing you 2 different ways, okay, depending on your comfort. I know some of you are able to solve for the variable x here, no problem, very quickly. But like I said, if you wish, use algebra tiles if needed. So this is the first example, which is a linear equation. And remember, we talked about what a linear equation means. You can see here there are 3 terms or 3 items right in front of us, right? So actually, I'm going to write this a little bit bigger. So that's 2x plus 3 equals 11. Okay, so the first method I'm going to do is I'm going to simply use or solving algebraically right off the bat, okay? And please write this down, okay? Write this down on your notes. It's very important. And please make sure you write it vertically, because I know some of us may tend to write horizontally, as I mentioned before, but please write this vertically so that it's in an organized way. So one thing to do vertically is to just simply write an equal sign underneath the equal sign above, okay? So this is what I meant by vertical writing. The first thing you want to do is you want to look at your number here. So keep your 2x as is. So I'm going to write that down. Actually, you know what? I'm not going to write this right now. I'm going to focus on the constant here. Okay, remember what a constant is. So you have a positive 3 here. Remember, the sign follows with the number, and then you have a positive 11. Okay, what to do at this step is simply you want to take your positive 3 and you want to move it over to the other side. And as I mentioned before, once you remove or put it over to the other side, imagine this is a bridge. If you want to get across the bridge or go somewhere else and jump onto the other side, you want to undo that. So instead of plus 3, what we should do is you want to take away 3, and what you do on one side of the equation, you have to apply to the other. So the reason why we do this is, well, who can tell me what is plus 3 take away 3? We got 3 things in front of you. Take away all 3 things. Wouldn't that just leaving you with nothing? That is right. There is nothing there. So that would be 0. And I know some of you are tempted to write plus 0. And that is, by all means, that is fine to do. But for now, what I'm going to do is I'm just going to leave that. Leave it alone. I'm not going to put a 0 there. And simply, I'm going to write 2x down here. And 11 minus 3, that would just be 8. Okay, so the equation is just going to be 2x equal to 8. I know it's a little bit lopsided here, but I hope that makes sense. So you can either take the positive 3 over to make into minus 3 to get 8, or what you can do is you can simply do what I did with blue ink, which is to take away 3 on both sides. Depending on your comfort, that is what we can do. Okay, now we have 2x equals to 8, our coefficient here. Okay, remember what a coefficient is? Our coefficient here is a 2, and not just any 2, it's a positive 2, okay? So what we should do is, because you have 2 times x, remember when there's nothing written in the middle, that is a multiply. Sometimes you can write an x, sometimes we write it with a dot. Doesn't matter, or sometimes we don't write it at all. So to get rid of the 2, we cannot just remove it across it out like this. I wish we could do that, but we can't. So instead, what we should do is you undo the multiplication, which is going to be divided by 2. Okay, so the opposite or the inverse of multiplication is dividing. Just like the inverse of addition is subtraction, we do dividing by 2 on both sides, which is just going to be x equals to 4. Now, how did I get x? Well, 2 divided by 2, it's just simply 1. And so you can write a 1 in front of that, but it's all good. You don't have to. So your final answer is just going to be x equals to 4. Okay? Same thing with this one. I'm just going to quickly write down this first, and then we're going to show you how to do this with algebra tiles. So one thing we can do here is the opposite or the inverse operation of minus is addition. And I'm going to just make some room here. I'm going to write this vertically. You can see this is a vertical. Here, I just want to show you that this is a vertical way, okay? So we're going to write vertically, okay? So now -3 or -3 plus 3 minus 3 plus 3 is actually 0. Now, if you don't see that, what we can do as a hint, as I mentioned before in class, is to switch this around so that it's plus 3 in the front and then minus 3 in the back. And we know 3 take away 3 would just be 0. Okay, so you can simply just flip that over if if it doesn't make sense to you. Switch the numbers with the sign around, and you'll get the same answer. Now that is gone, so I'm gonna go ahead and I'm going to write. Actually, I don't need to write 0, so I'm just going to leave it and blank here with a blank space. And 7 plus 3, that is just going to be 10. And in that case, as we mentioned already, we're going to divide both sides by 2 to cancel out the coefficient, which you will get x equal to 5. Okay, so you can you can write it like this, or if you want, we're going to go ahead with algebra tiles. This is going to be try the third one, but this one we're going to, before we do that, we're going to try with algebra tiles, okay? So because of, I don't have the tiles here in front of me for the sake of this lesson here, I'm just going to simply write it all out, okay? So I'm going to write it down again. So that's 2x plus 3 equals to 11. So that was your method number 1, okay? And this is your method number 2. Okay, so as we mentioned before, and because we have already had a basic knowledge or understanding of algebra or polynomial, this is what we're going to do. 2x is going to be represented with the strip. So we're going to call this an x and an x, okay? Now I'm gonna, I know you guys have a physical copy or physical tools or manipulatives for this, so it's easier to do for me because I'm writing this on notes here. So this is just going to be represented by a positive x and another positive x. I'm going to let blue be positive and red be negative, okay? So this is going to be positive, and I'm just going to put this to be negative. You can pick any color you want, doesn't matter, or you can use any color of tiles you wish, but I'm simply going to use blue for positive and red for negative. So that is done, okay? 2x, there are too many x's, okay? And now what we're going to do is, because that's positive 3, I'm going to draw out 3 counters or 3 algebra tiles that represent the constant here, okay? And for 11, you know what? To be safe, I'm just going to write an equal sign there so that you understand or you're able to follow along here. So 11, I'm just going to go ahead and draw 11 algebra tiles, and each represents a positive 1. Okay, again, so this is a recall or a summary from what we learned in the previous chapter, which is on polynomial, which makes sense now that we're doing solving. It's simply a continuation of what we learned earlier, okay? So that's 1, 2, 3, 4. So now that's 10 and 11 there, okay? So again, each represents a positive 1. I'm just gonna remove the positive. Now you know that it's 1, okay? So there are 11 here, 3 there, and 2 x's, because that's what it represents. Now, because I don't want the 3, okay? So I want to take this, and I want to shuffle to the other side, okay? So once we do that, so what we're doing, simply by removing or pushing that over, we're just going to add 3 negative tiles, okay? The reason why we do negative, as you remember from above, what we just said earlier, okay, is so that we can simply get rid of that, or simply, well, you can use your tiles physically in front of you and then you move it over. The process of moving over is the same thing as just getting rid of these positive blue tiles by putting -3 3 red tiles here, okay? So now that it's gone, now this step is over. Don't forget, I'm also removing 3 or taking away 3, okay, from the right side. So in this case, what do we have now? So this is gone. Now 11, we remove 3, so that is simply going to be, you know what, instead of writing that, I'm just going to take away, okay? So I'm going to remove 1, 2, 3. So we're going to remove 3 here, which, how many do we have left? How many blue? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 positive tiles on the right side. Okay? You know, it's much easier if you have a tiles in front of you and you can do it all at the same time, but because I don't, I'm simply just going to show you with this. Okay, so I'm crossing it out. Now we have 8 remaining. Okay, there are 8 tiles remaining. Now what we're gonna do is, well, we don't forget the 2 x's here, so we still got 2 x's. So that's one x and another positive x, so there are 2 x's, okay? Now, simply speaking, everything is good. We're at the step, we're happy, but we're not done yet, because now you're trying to think up how can we make sure to fit your 8 blue tiles in the in your variables, okay? I don't know what's going on here. So we want to fit this all in your variables. Huh, interesting. I think I may have, okay, in here, okay? But you want to fit it evenly, okay? Hopefully it can fit evenly. So what we should do is, in your own tiles here, how many, or if you can find out what strategies or how many ways you can fit 8 tiles evenly, so very nicely with no remainder, very evenly into these 2 rectangle boxes. So if you do that, you're probably going to get something like this. Whoops. So let's say that you got, so this is 1, 2, 3, 4. 1, 2, 3, 4. So as you can see, we still have 8 tiles, right? We're not removing or adding any tiles, and we're not removing any x tiles here. So in this case, we can simply say that for each x, okay, so that's an x, and that's an x. So for each x, we have 4 tiles, right? We got 4 little counters. So you can say your x equals to 4. All right, does that make sense? So now we can try another one here, but this time we're going to try with, so I'm going to move it down here. So this time we're going to try with -3, okay? And so you can remove your tiles, and we're just simply going to go ahead with this one. And so that's 2x here, x's here, and then because it's a -3, remember your sign comes with your constant. Okay, a lot of people forget that part, so please be careful. That equals to +7. 1, 2, 3, 4. Okay, so there we go. There are 7 algebra tiles, and in this case, we want to, like I said, I want to collect the like terms by putting them together, right? So in this case, I want to take that over. Well, what should we do? Is we're simply going to add these tiles. Okay, so we're going to add 3 blues, so that actually going to cancel out, as we mentioned this above right here. When you add -3 plus 3, 0. So in this case, that's gone. And here we're just simply going to add 3 more. So what I'm going to do is we're going to represent it using dots. Okay, so we're adding 1, 2, 3. Okay, so because we added there with the green arrow, now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So down here, we have 10 10 tiles here. And what do we do with the 2 x's? You got 2x here? Well, nothing. 2x just stays where you are, and now you're gonna come up with a strategy knowing, okay, how can we fit this in here? Whoops. Let me change the color. I don't know why the color. There it goes. So we can put this blue, that 1, 2, 3, 4, 5, right? And then we're going to fit the other down here. 1, 2, 3, 4, 5, and go ahead and place that. And I know it's a little messy here. As I said, it would be so much easier if I actually have the tiles in front of me. So if you don't really see this here, let me just show you in another way, maybe a little more clearly. 1, 2. Okay, there we go. So now we have that. So what does this mean? So this simply means, so therefore, your x, so for each x, how many counters do we have? We have 5. So this is our answer, x equal to 5. And please go ahead and write that on your whiteboard. So as you can check that x equal to 5, that we solved it algebraically, and if you want to use algebra tiles, and that is the same answer. So once again, just to give a little quick recap, make sure you look at your terms, okay? So you got 3 terms here, 1, 2, 3. Be careful. You got to look at the sign in front of the constant or in front of the coefficient, because I know it's something that it's often overlooked. So then we draw 2 x's here, and we have 3 to represent the negative. So red represent negative, and 7 blues, okay? And to undo or the inverse of red is to add 3. So if you want to put 3 blues on there, you're going to put 3 blues over here on the right side as well. On the left side, the red and the blue cancel out, leaving you with 10 blues on the right side. So now we're just going to try to simply fit these counters, which is represented by positive 1s. Okay, we're going to take all these positive 1s and we're going to squeeze in there into your variable. So now your variable x is actually 5. Okay, so there it is, guys. I want you guys to go ahead and write down your third example. I know it's kind of hard to see here, but your example number 3 is going to be 1/2 x plus 4 equals to 7. So try this out yourself, and I'll give you guys maybe 5 to 10 minutes. Try to think about it, and once you're done, you can check with your partner or with someone you haven't worked before, or check with your teachers like me if you have any questions. Okay, we'll come back in a few more minutes. Thanks.